Start from here. Today we have 3 presentations. This was what we had discussed yesterday. So let's start from here. Yes, biostatistic is a collection of data. Okay, it's a presentation of collected data, and we are going to do analysis and we are going to interpret this analysis. This is the most important part where we need statistics, because there are lots of programs who can calculate, like Stata, like SPSS, like Lizrel. There are lots of statistical programs. Excel, but the interpretation is the most important part here, because if we can interpret it true, then we will be successful. And if we interpret it wrong, then it may result in very important conclusions, especially in health. Wrong interpretation is very dangerous. It's human health, and if you wrongly interpret, for example, a medicine is useful as a result of the analysis that you delivered, then and if you use it and if interpretation is wrong, you understand it wrong, and it will be very, very dangerous, and it will be result in persons losing health. Okay, so we are using frequencies. So recorded data. Recording data is another important thing, and we are having sample data in our surveys. So there are lots of statistical procedures and techniques. There are lots of statistical procedures and techniques. But the most important thing is choosing the right statistics. That's why that we need these courses. I can open SPSS and I can calculate lots of tests, independent t-test, ANOVA, and Mann-Whitney test. There are lots of tests, but when we can use which test is the most important thing. When, in which situation I should use independent t-test, in which situation I should use ANOVA, and in which situation I should have, let us say, a correlation test. Okay, so it's important to know. And if I have results like 0.03, what this means? What is the meaning of 0.02? Is it something that I want, or is it something that I don't want? This is important. So which technique, which procedure? Okay, so there are lots of sources of data that we can get for our research. Records. We can record our patients. We can say we should have records, of course, how many times they come to us, and what is their problem, and how we fix them. Okay, you know that in these days most dentists are have many patients, therefore they don't have very good records about what was the problem. Okay, they are having appointment records, but they don't have like, okay, the problem was there was a decay or there was a broken teeth. Okay, they are not properly recording it, but recording it is a statistical thing and provides us data for our researchers for predicting what we should do later. What it would help us, okay, this patient had 2 broken teeth, and this year again, so she may have other problem like stress and night clamping teeth, the different things, and it's a continuous thing, so everything gives us a clue. So recording is important for all the health workers or doctors, nurses, everyone, as well as teachers and every person, in fact, every business. Recording is very important. Surveys, yes, if we want to have an information about whether a method is useful or not, especially these days, you are seeing lots of results of surveys each night on TVs all over the world, and you know that it is COVID-19 surveys and statistics, you are seeing them. This is important, and interpreting is important. They are not just presenting the data to you, they are interpreting it. And again, we are doing surveys and we are interpreting. Experiments, yes, that's trials. Okay, we have 2 medicines and we are trying, okay, if I give this first medicine to first group of patients of which are 100 patients, and that if I give the second medicine to the other 100 patients, observing the difference is an experiment. And surveys can be comprehensive, detailed, or a sample. Yes, we can have types of data. We can have variables. You must be familiar with maths like x, y, z. They can change. And constants. For example, what is a constant? Sex is a constant. Female, male. A person is either female or male. Or what else is constant? For example, nationality or native language is a constant. For example, Turkish, Arabic, English, these are constant. Native language. And variables, they are maybe blood pressure is a variable, it changes. The number of problematic teeth, it changes in time. In 2015, the person may have no problems at teeth, and 4 years later may have lots of problems. So it changes, it's a variable. So constant is something which doesn't change, and variables are the changing data. Yes, let us talk about types of variables, quantitative variables and qualitative variables. Quantitative variables are the variables that we can count. For example, 5, 6, or the height of a person, 1.722 meters. The height or the weight, 62 pounds. The weight, and these are quantitative, the number of things, or maybe what else, when we measure results of some measurement are quantitative variables. They can be continuous or they can be not continuous. Discrete, they can be not continuous. Continuous, when they are continuous, for example, weight is a continuous variable. Why? Because, let me write here, okay. Let us say weight 1.72, okay, let us say 1. Ah, really? Okay. Yes, I started recording this again. So what was I saying? That there can be different sources of data, records, surveys, experiments, and here there can be types of data, quantitative, qualitative data, and I was giving examples of height. Okay, height is a continuous variable. It is a continuous variable. Okay, why? Because a person, let us say, is at this height, and it can, in time, it can be this height. Okay, but what this means that he grows little by little. At first he becomes 1.13, then 1.14, then 1.15, and it grows, it's a continuous thing. For example, not continuous, number of children is not continuous variable. Okay, not continuous. Okay, here number of children is not continuous. Why? It may be one, 2, 3, but it is never it is never 1.5. Okay, you don't say 1.5 children. I don't have, it's not true. Okay, the expression is not true. You don't have decimal points for children. Okay, so for example, number of problematic teeth. Okay, when you are saying it, you say maybe 2, 3, 4, 7. Okay, but you don't say 3.5. She has 3.5 problematic teeth, not 3.5. Okay, it's not true saying that. You always say 3, 5 or 2, whatever it is, but never with decimals. Or you don't say, you cannot say 3.21. It's not something that is good to say like that. It's not true. So what is true is that you can say 3, 5, 7. And what this means, this is not continuous. Okay. So would you like to give me examples of continuous and not continuous variables? This record, and I went to my presentation. Okay. So here we can have numerical presentation. I didn't share my screen. I think no. Yes, I know. I remembered it now. I am sharing my screen. Yes, and I return to my presentation. Now you can see it. Numerical presentation and graphical presentation and mathematical presentation. There are different types of presentations. Now, frequency. Frequency is the number of things, and percentage is the amount that is in a row. So we represent in tables the frequencies and the percentages. For example, here we have an example: distribution of 50 patients at the surgical department of Alexandria Hospital in May 2008, according to their blood groups. Okay, so this is A. Okay, blood group A. There are 12 patients with blood group A. When you see frequency, it means number. 12 people with blood group A. So there are 8 people with blood group B. I can have it like this. Yes, and I can use my okay. So here it's begun like that. With blood group B, let us say there are 18. Frequency is 18. What it means, frequency 18? 18 people, 18 patients, okay? 18 patients with blood group B. Okay, what is this? This 18 is out of 50. If it is out of 50, 18, its percentage is 36. So when we express it as a percentage, we mean out of 100. Out of 100 is 36. Okay, the blood group AB, there are 5 people from blood group AB. Again, frequency is the number. We don't say number in biostatistics. We use the word, the keyword frequency. We always use the frequency. This is the method that you can see in many papers, that they express it like frequency and percentage. Okay, so AB is 5. It means number of people with who has blood group AB is 5, and This 5 is in fact out of 50. What is it is out of 100? Out of 100 is 10. So this is blood group O. There are 15 people. So altogether, this frequency total there were 50 people. So these are the numbers of people who has blood group A, B, AB or O. And these are the percentages. So this is the statistics, this is biostatistics, this is the basic of biostatistics. We will talk every day from now on with frequencies and percentages. And in order to get some information, we should always look to percentages. It gives us more clue. So out of 100, it is like that. So there may be different cases, okay? For example, 15 people out of 50 is 30 in fact out of 100. We will see different examples. We can have tables according to age. So in biostatistics, what we do, we have tables. This is blood group tables, okay? And here we have age tables. In this age table, we group people, okay? We always group people to get some information. This is people between 20 and 30, people above 30, people above 40, people above 50. And frequency is the number of patients in this hospital who are above between this 20 and 30 or above 30, and the age of people who are above 40 is 5, and who are above 50 is 15. And these numbers, this frequency is out of 50. Altogether, if I add, these are 50. And these are the numbers out of 100. As I say, we don't say numbers in biostatistics, we always say frequency. This is the key word for us. And the representation of percentage, we don't write percentage. We should have some notation now, some ways of representing this, some universal ways that everyone can understand. So with this percentage, we mean the number out of 100. What is the number out of 100? Yes, this is another table, another biostatistical table. Now this is a frequency distribution table, okay? This table is called frequency distribution table. Why? You can see different frequencies. Now here, in fact, these are frequencies. I read it like no, but these are frequencies. Okay, this is also frequencies, and this is also frequencies. This is frequency distribution table. Okay, we have some percentages, but in the statistical programs, you will see that this is saved as with this name. Okay, so if I want you to write the frequency distribution table, you will write the frequencies and the percentages. Okay, so here we have a lung cancer case, okay, and the cases and the control. So when we are delivering a research study, we have to have, let us say that we are using a medicine, okay, and we should have a control group where we don't use that medicine, okay, because you know that the most important thing in health area is which medicine that we should use, which method that we should use to help our patients. So this is the main researches that are delivered all around the world. So we have control cases and we have other cases. So this control means control group is the group where we have we don't give any medicine or we don't apply any method. Okay, this is the control group. And here, this is the real cases, the other cases where we apply some medicine. Smoker, and in our, let us interpret this table. So I will give you tables like this, and I will want you to interpret it, okay? I will ask you, for example, how many smokers are there in the control group, okay? So smoker is here, and control group is here. So how many? 8, okay? Or I can ask you, what is the percentage of the cases of non-smokers, okay? So these are the cases. What is the percentage of lung cancer cases of non-smokers? Okay, this is cases, and this is non-smokers. Okay, so percent. If I ask percentage, you will say 25%. So I will ask you a question now. I'm at this table, and I'm going to record at the same time, and let us continue where we left. Okay, so what we have seen, we were discussing the frequency tables. Okay, frequency table is a table where we can see the frequencies, the numbers, and the percentages. This type of tables are frequency tables. This is a complex table. We can have easier tables. This is an easier frequency table. These are all about biology, human health, and so it's subjects of biostatistics. Okay. Yes, we will discuss smokers, non-smokers. Now, let us talk about graphs and the rules. So, there are lots of line graphs, okay, frequency polygons, histograms, bar graphs, scatter graphs, and pie charts. And also there are statistical maps. Okay, so this is a graphic, simple graphic, okay, simple graph. We may have line graphs. This is called line graphs. When we want to show distribution over time. Okay, so when you can use line graphs, you can use line graphs to show distribution over time. Here, maternal mortality rate of countries, this, or rate of birth in years, the difference of rate of birth among years. This is a line graph, okay? Or the cancer patients diagnosed each year in Turkey, let us say, okay? We should have some restrictions to our experiments, okay? So cancer patients, but where? In Turkey, in Cyprus, in let us say England, or so we have to mention where we are having our research. Cancer patients in Turkey. So distributions of cancer patients among years in Turkey. We can express it as line graphs. So changes among years can be presented in line graphs. We can have frequency polygons. Yes, there is a message about, is it from Big Blue Button? So it's from Telegram. Let's say, okay, I don't know. Hilda is writing something. Okay, we can help her later. I have to continue now. We'll help her later. Okay, so here we have a table, okay? And in this table, let us interpret this table. Our job in biostatistics is interpreting, okay? This is statistics. Everything related with frequencies and percentages is statistics. And interpreting is a person's job who knows statistics. So let us see what we have here. 3 is number, okay? 9 is number, 7 is we have numbers here. And in brackets, we have percentages. Here we have numbers and we have percentages. And we have midpoint intervals. We have, you see that this is a different calculation. Here the interval, midpoint interval. We will see this how we calculate it later, not now. So this is a frequency table that we can have a frequency polygon. So what is this polygon? Let us look. We have two variables, okay? We have males and females. These are constant variables. Okay, this is constant data. They don't change. A person is either a male or a female. Okay, so we are going to express it. This is its age, okay? And we have some values here. Okay, you see distribution of age and sex, gender here. For example, this here shows that this purple line shows distribution of females. So you see that here until here, females are lower than males. Okay, and the male patients here around 45 is less than females. You see that the purple line is above. So here male patients is less than females because purple line is above. And then here what we see again, the female patients above 65 is higher than male patients with ages 65. Okay, so as the line goes from 55 to 65, we see that there is a decrease in the male patients. Okay, this is the frequency polygon, and we have a curve. This is a curve. Okay, you see that this is a curve. So this is a polygon. This is a line graph. Okay, and this is a curve. Okay, and in this curve, what we see that age in years. So we have two different expressions again. So male, let us look to the graph. Male is expressed as this continuous line with a square in the middle. Okay, it is just a way of showing it. We have to find two different expressions. So this expression, this curve shows distribution of male, and these distributions have female. So this is also possible. So this way of showing and this way of showing is also possible. Okay. Histogram. This is a histogram. This is the distribution of, for example, cholera patients by age. So we have cholera patients, and we have these are frequencies. We have 3 people above the age 25. So this means above 25 and below 30. Okay, this expression means here like 25, above 25, and this is above 30, this is above 40, this is above 45, and this is between 60 and 65. Okay, these are the numbers, and these are the percentages. So you can see here in histogram we are using percentages. Okay, we are using percentages, not the frequencies. We are using percentages, and we are saying, okay, between 25 and 30. Okay, between 25 and 30. Okay, we have about 14.3. Okay, and here we see that above 30 and of course below 14. Above 30, 30 is here. Okay, until below 30, until here. So this is also 23.8. So look here, this is about 23.8. Now, why this is two rectangles? Because it goes 5, 5, 5. Okay, this is 5, so one rectangle. So it is it has 2 5s. Okay, 5 and 5. So it has 2 rectangles. And here there is 1 rectangle. So this is an expression in histogram. And this is bar chart. Bar chart is not continuous. Okay, bar chart is not continuous. Here, single patients. Okay, married patients, divorced patients, widowed patients. So a person is either single or married. It doesn't continue. No, okay, it's there. We don't categorize them as in the middle. We don't say single or married. Okay, complex relationships is not something that we deal in statistics. Either single, married, divorced, we don't. Okay, so this is a bar chart expression. And this is a pie chart expression. In pie charts, we have percentages, okay? We don't have frequencies. We don't use frequencies. We have percentages, and the biggest pie shows us the bigger percentage. Bigger pie shows the bigger percentage. And this one, okay, is percentages, bar charts percentage, histograms percentages. Here, frequencies, curves are frequencies, and polygons are percentages, okay? Yes, and there was one more. Yes, here lines are here frequencies, okay? So we use different percentages or frequencies for different representations, and this is called donut chart. Okay, this is so what I expect from you. I expect you to know the names. Okay, if I show you this is a donut chart. I expect you to say, I will not write the name. I expect you to say this is a bar chart representation, and also I will expect you in your exams. I will expect you to say, okay, it's continuous, so it is histogram. Okay. I will expect you to know the names of these things. So this is a frequency curve. I will not want you to draw graphs, but I will want you to interpret them, know the names. Is there anyone who wants to say anything? I can stop this, so I continue to record. So we are saying, I'm not sharing my screen, but I think I forgot sharing my screen, so I remember it now. Okay, I'm sharing it, and yes, I'm here. Okay, good. So yes, there are lots of different representations. So yes, we are going to see some definitions. Okay, mid-range. So what is mid-range? Smallest observation plus largest observation divided by 2 is the mid-range. Okay, these are just terms that we use in statistics. So for example, smallest blood pressure and plus highest blood pressure divided by 2 is the mid-range of the blood pressure measurements of a group of people. So mode is the highest frequency, okay, highest number, the greatest number, okay. These are just definitions. Range is the difference, okay. Range is the difference of the biggest one and the smallest one, and we will see the others also. Okay, so let us say that we have 3 different groups here, okay. So we have in the first group we have 7, 7, 7, 7, 7, 7. So what is mode here? What is the mode is the repeated one. Mode is 7, by the way. Okay, mode is 7. Let me say here. Which one is more repeated? The mode is 7 again. We don't have repeated 8 and 6. So this is another group of patients that I say, and these are just some measurements. So here, which one is repeated? We don't have any repeated value here. So we either say that we don't have a mode, okay? If we don't have a repeated value, we say that the common way of saying is that we don't have a mode. We don't have a repeated value here. So once again, mode is 7. Mode is 7 because the repeated value here is 7. Let us say we have 8 more 8 here. Let us make it like that. So now one more 8 and one more 8. So let us count. So we have 1, 2, 3, 4, 5, 6, 7, right? I have 7, 8. Okay, the number of 8 here is 7. 1, 2, 3, 4, 5, 7. Okay, and the number of 7 here is 4. So here the mode is 8, not 7. Why? Because 8 is repeated more. Okay, the number.
About the mode or the mean? Because your
Yes, that's better. So mode is 7. Okay, and here again the most repeated one mode is 7. Okay, and here again let me write it. Okay, here the mode is 7. Okay. Oh no mode. We don't have mode. But we say we don't have mode because there's not repeated one. Okay, mode is the most repeated one. But mean, why is mean? Mean is what we, when we add this and divide 1, 2, 3, 4, 5, 6. So we have 6, 7 here. So 7 add these numbers and divide by 6, you will have mean 7. Okay, this mean is arithmetic mean. So here, what you are going to do, find mean, you have to add this 7, 8, and all these values here. You know that what I said to Excel is a perfect statistical tool that you can always use for calculation. So here, okay, I will copy the numbers. Okay, this is it. So, where is Excel? I open too many windows. You see, when I open too many windows, it may be confusing. No, this is another program. Even WhatsApp is opened. Just a moment. Here's my Excel. Here. Okay, so. Okay, I cannot do it, but I will have it here. This one. A few minutes until I fix my programs because I opened too many. Yes. Okay. Well, it's better like this. Okay, so here I have 7. 8, as you can see, 1, 2, 3, 7, and 6. Okay, so Excel can calculate us directly here. If we just select them, you can see here just a moment, where is the mean, maximum, minimum, average. Yes, average is the yes, it says here, but yes, average is that here. It was closing, my screen recording was closing the average there. So average is the mean. In fact, in Excel, what you see, you can see, I think here, this average 7. Okay, so here, so I am trying to say that here, even we have different numbers, it's possible that we have same mean. Okay, we have same mean, we have different numbers, but we have same mean. So here, I think I cannot copy from the shape there, so I'm going to write 2, 7, 8, and 13, and 9. Okay, so I select them, and I see that average is 7. Okay, so minimum is 2, maximum is 13. So the range is, what is the range? Range is 11. So why? Because it is the difference between maximum and minimum. I can also write here the range is 11. And here the range is 2. And here the range is 0. Okay? Okay. So these are the different expressions here. So we have different numbers. We have 2, 5, 6 numbers. We have 6 numbers, and we have 6 numbers. Okay, 6, 6, 6. We have 6 numbers. Let us say that we have 6 different patients, okay? And their measurements are different here. These all have 7, these all have, one has 8 and 6, and one have 2, 3, 8. This is a more different one. But we can have same mean. We can have same mean. Even we have different patients with different measurements, we can have same mean. That's what it shows here. Okay, but this is also a good example of a standard deviation. Okay, what is the standard deviation? Since they are same, when all the measurements are same, standard deviation is 0. Here, standard deviation is 0.63 because they are not very different. Okay, here when they are very different, standard deviation is high. So when standard deviation is high, when the measurements are different from each other, the more that the measurements are different from each other, then the more higher is the standard deviation. Here it is lower because they are more close, and this is again this is 0 because they are same. By the way, I want to say also median. I don't have space here to write, so let us write the median. What is the median here? Okay, median.
Can we calculate the standard deviation?
How can you calculate what?
Standard deviation.
We don't. This is as here. Okay, standard deviation is at here. It is a measure of variability among means of samples selected from the certain population. So it's here this S over square root of n. But I will not want you to calculate standard error or standard deviation. I will want you just to interpret it, okay? So I will want you to know, I don't want you to calculate whether it is 0. Just know when they are same, it's 0. This is enough, okay? And know when they are different. The more that they are different, then the higher the standard deviation. So you will not need to calculate it. So don't worry about it. But you need to calculate median. Okay, you have to calculate mode, mean, and median, but not standard deviation. Median. Let us see median, how we are going to calculate it. Median, we have to arrange these numbers, okay, in order. So let me have it in a bigger form. I have to open it. A little bit bigger, okay. Now close it. Okay. So here, just arrangements. It's better like this. Okay. More emphasizing. Okay. Now here, I am going to calculate median. Okay, the first one. What I do, I write here in order. Okay. So how many numbers? I should have 6 numbers here. Okay. So the median is, if you have even numbers, the median is this in the middle here. Okay. The second and fourth one, you add these two and divide by 2. So, but it is again 7 here. Okay. So 7, everything is 7. So median is 7. So let us calculate it with this one. We are going to calculate it here. The second one, we have 7s and we have 1 8. Okay. So we have 7 and 7, 7, 7 and 6 and 8. Okay. So, but we have to order this. Okay. These are the numbers. We have to put them in order. We have to put them in order. This is the order. We have to order them. I ordered them. After I ordered them, the rule of the median is to have, if it is, let us say 6, I divide it by 2 and I have 3. So I have third and fourth values and divide by 2. and median is again 7 in this question. And let us come to here. I am going to reach to another important conclusion. That's why that I am having this calculations now. So in my shape, okay. This one. Let us calculate median again. So in for calculating median, just a moment. My shapes. Okay, I can write here. So I can see them. This is the smallest one is 2, 3. I have 2, 3, and I have 7, 8, and 9 and 13. Okay, so good. Here again the middle. Is it right? 2, 3, 7, 8, 9, 13. Okay, good. So I add these two, 7 plus 8, and divide by 2. So it is 7.5. Okay. So median here, mean. I didn't write median. So median is 7.5. Okay, here median is 7.5. Good. So here, this distribution over here and this distribution are normal distributions. However, this one is not normal distribution. How do we understand that? The important thing here is the values of mean, mode, and median. Yes, normal distribution. I'm going to add one more slide here. Normal distribution is a case where we have this is a table. I don't want a table. Okay. Normal distribution is the case where mean is equal to mode equals to median. Okay. This is our first formula. And here in shape 1, let us say that this is 1, figure 1. I'm going to put a number. This is 1. Okay. This is 1. And this is 2. Okay, this is 2. And the other one is 3. This is 2 and this is 3. This is 3. Okay, so the first. So here, okay, let us have another text box. So first distribution, first and second distribution, or the population or the group, let us say group, shows normal distribution. This is a keyword in biostatistics and it is really important. I will explain why in the following course. Distribution, okay? And third group, okay, it doesn't pass to the other way. It's also so tired, I think. Okay, third is not normal. Is not normal distribution. Why? Because here we have mean equal to mean doesn't equal to median, and we have no mode. Okay, so here mean is not equal to, I can express it like that, median, and we have no mode. Okay. So in order to have normal distribution, we have to have mean, median, mode equal. Here we see something as with the standard deviation. Even we have normal distribution, they can have different standard deviations. This is another important thing here. So let me write this also. Not for standard deviation. Important not for standard deviation. Important not for standard deviation. So even two distributions or two groups show normal distribution, they may have different standard deviations. This is the keynote, important note of today's course. So standard deviations may be different. It is the difference of our measurements in a group. As I said, I will not want you to calculate it. Only you have to know how to calculate mode, mean, and median by heart. Okay. Mode is the most repeated value here. Mean is when you arrange them in order. If it is an odd number, if it is 7 numbers. So let us say that we have 7 numbers, equation like that. If we have one more number here, let us say we have 7 numbers here. So we find here the median like this. Median is the number in the middle, so median is this one, 8. Okay. So if we have 7 numbers, then here the median is this one. And if we have, okay, here we had 6 numbers. What we do, we divide the 2, we add the 2 in the middle and we divide by 2. So this is how we calculate median, okay? And mean is arithmetic mean, and when we have average here, you cannot see it from this screen recording, but when we have average here, then it is mean, okay? Yes, that's all for today. I will stop.